This is RD Sharma solution, class 12th. Differentiation, chapter 11, exercise is 11.2. If y is equal to x sine inverse x plus under root 1 minus x square, we have to prove that dy by dx is equal to sine inverse x. Now, how you have to write? That is, we have differentiate, and wherever it is product rule or chain rule, whatever comes, you have to write. And we have to give the resultant as sine inverse x. So when we perform dy by dx, the first one is x sine inverse x. So we will be performing product rule x sine inverse x. So first x, then d by dx of sine inverse x, followed by an addition, then sine inverse x, and d by dx of x, differentiation of x. Now this is x, sine inverse x is under root 1 minus x square. Then we have a plus sign, sine inverse x, and d by dx of x is 1. Differentiation of x is 1. Okay, now the differentiation of the second part, which is under root 1 minus x square. So 1 by twice of under root 1 minus x square, whatever is under root, it will be 1 by twice of that thing. And then 1 minus x square, 1 is 0, x square will be 2x, so it will be negative 2x. So I am cancelling the 2, putting the negative. So what will be remaining? Only x. 2 gets cancelled, negative sign we have used, x by under root 1 minus x square. So what do you see here? The first term and the third term, this term and this term, they will get cancelled. Only sine inverse will remain. So this is how dy by dx is sine inverse x. So this is how you have to write, because we have used the product rule. So you have to write incomplete product rule like that. Y is equal to under root x square plus a square. We have to prove that y dy by dx minus x is equal to 0. So this is not a very heavy question. We can easily do, and you have already seen. So this is y equals under root x square plus a square, and this is dy by dx. Normally we will do what? Dy by dx and d by dx of that thing, x square plus a square under root. But the better way is, because we need y dy by dx, and that will only come, or that may come, when we square both the sides. So when we do the square, y square will be equal to x square plus a square, and the y square differentiation is 2y dy by dx, and this right hand side x square will be 2x, and this a square will be 0. It is a constant. So 2 gets cancelled, y dy by dx, x we take on the left hand side, so y dy by dx minus x is going to be equal to 0. Next is y is equal to e to the power x plus e to the power minus x. So dy by dx is under root y square minus 4. So there is a formula we are going to employ or use here, and that will be, see, y is equal to e to the power x plus e to the power minus x. Simple differentiation will do d by dx. E to the power x will remain e to the power x. E to the power minus x will remain as e to the power minus x, but we will have a negative sign because minus x is also there. It will be negative here. Alright. Now, how to convert this in this form? Because we need under root. So we'll apply the formula, and we already know there is a formula, that is a minus b whole square, or a plus b whole square. A minus b whole square is what? 4ab. I'll show you how it will come. A square plus b square plus 2ab it will be, and minus a square plus b square minus 2ab. So a square plus b square plus 2ab minus a square minus b square plus 2ab. A square cancel, b square cancel, 2ab will be 4ab. So we have to write this e raised x minus e raised minus x. So when we need the a minus b, what we'll do? We'll take the 4ab with the a plus b whole square. So a minus b final will be, a minus b will be under root a plus b whole square minus 4ab, the way I explained you. So this is a, this is b in our case. So let us write like this: a plus b whole square So we have e to the power x plus e to the power minus x whole square, and minus 4 into a into b. What is a? E raise x. What is b? E raise minus x. The power gets added. X plus minus x, that is x minus x is 0. So e to the power 0, that is going to be 1. Alright. So this e raise x plus e raise minus x was what? Initially it was y. The question was saying y. So y square minus 4 under root. So this started all from dy by dx. So this is dy by dx. And that is what we have to prove. Alright. Y is equal to under root a squared minus x square. Prove that y dy by dx plus x is equal to 0. Now this you can try because this is quite easy. But for the completion I'll do it. Dy by dx. Now what we will do here is same thing. What we have done in the one of the previous question. We are going to square it. Alright. So this is going to be a square minus x square. You can do that like that, but we'll square it. So when we square it, y square is equal to a square minus x square. So this is y square, so it will be y square will be 2y, and y is dy by dx, and a square will be 0, and this is going to be minus 2x. 2 gets cancelled. X on the left hand side bring y dy by dx plus x is equal to 0. This is your final answer. You have to write like this, okay? Squaring both sides, differentiating it with respect to x. This all thing you have to write. If x multiplied by y is equal to 4, prove that x into dy by dx plus y square equals 3y. So there are so many things which we will do here, okay? So you have to be very careful. So y equals 4. So what we'll do here is one time we'll put x as 4 by y. One time we'll put y as 4 by x, wherever it is required. We won't be using this xy equals to 4 anywhere. Mind it. This 4 by x dy by dx, so when you do the differentiation of 4 by x, you can assume it to be u, v, and you can do the differentiation in the question form, but 4 is a constant, so you don't have to worry about that. You just have to differentiate 1 by x. So x can be taken to the numerator, it will be x to the power minus 1. And differentiation of x to the power minus 1 is 4. Minus 1 will come in front. X to the power minus 1 minus 1. So finally you will get 4 negative 1 to the power x square. And that is when you bring this x to the power minus 2 in the denominator, it is going to be minus 4 by x square. So dy by dx, still we are not getting the answer. So we have to do certain more thing. Now xy is equal to 4. And what did you write? Y equals 4 by x or x equal to 4 by y? X is 4 by y. Now you can put it here. Minus 4 in place of x square you can write. This is 4. 4 is 16. Y square goes up because it will be in the denominator. So it goes up in the numerator. 4 gets cancelled. There will be minus y square divided by 4. This is dy by dx. Still we are not getting the answer. So 4 will bring on the left hand side. It will be 4 dy by dx equals minus y square by 4. Still things are pending. So this minus, we need a 3. So how can we get 3 from 4 getting minus 1? So 3 minus 4 is minus 1. That we know already. So in place of minus y square we can write 3 minus 4y square. In place of minus 1 we can write this, and we can also write 3y square minus 4y square. So 3y square minus 4y square, it is 4 into dy by dx. Alright. So this is 4y square I am taking on the left hand side. So what do we get finally is 4 dy by dx plus y square is equal to 3y square. Still we need some answer. So we divide both sides by x now. And what is xy equals 4? 4 by x is y. So in place of this you can write y. Dy by dx plus y square is equal to 3y square by 4, 3y square by x. Now you can change the position of x and y. In place of x, you can take it on the left hand side, y on the right hand side in the denominator. So x dy by dx plus y square is equal to 3y square by y. Y gets cancelled. So 3y x into dy by dx plus y square is equal to 3y. Final answer. This is the final answer. There are certain things which need to be explained here. Now here there will be some effort. The only effort is algebra, nothing else. Okay. The question is quite easy. Finally, you will see that under root a square minus x square will come. And how you have to write, I gave you in the answer already. So we'll do the differentiation. There are two parts. X by 2 under root a square minus x square, assume it to be a square by 2 sin inverse x by a, assume it to be b, capital A, capital B. And then we'll differentiate the dA by dx, for example. So x by 2 is half, I am taking outside. So we have x under root a square minus x square. So x under d by dx of under root a square minus x square plus under root a square minus x square, d by dx of x. I am not writing that because d by dx of x is 1. Half x by 2, half I have already taken outside. So half already taken outside, x d by dx of under root a square minus x square. So 1 by 2 twice of under root a square minus x square. And a square minus x square, of course we have already seen a square will be 0. It will be minus 2x basically. So minus 2x, let me write minus, 2 gets cancelled, x will be x square. So I have taken minus 2x, put in here and solved it in this step only. 2 I cancelled, x I combined with x, so it will be x square and negative sign. Plus under root a square minus x square. Now let us solve this first. Okay. So I told you how to take the LCM. So minus x square I am writing here. Root gets cancelled. So a square minus x square. And divide by under root a square minus x square. 2 is already there outside. So we will get a squared minus 2x square by under root a square minus x square. And half is already there. And so this is just this first part. Second part, we don't need to apply the product rule. Why? Because a square by 2 is entirely constant. So we don't have to worry about a square by 2. You can just keep it like that. So a square by 2, we'll talk about that later. But sin inverse anything will be 1 by under root 1 minus of that thing square. So 1 by under root 1 minus x square by a square. 1 minus x square by a square. Differentiation of x by a is simply 1 by a only, because d by dx of x is 1. 1 by a. Okay. So 1 by a will come outside. Okay. So a square by 2 was already there. 1 by a gets cancelled. So you'll get a by 2. Only a by 2. Now let us concentrate on this. It is in the denominator. So it will be a square minus x square by a square under root. And under root a square in the denominator will go in the numerator. So it will be a only. Under root a square is a only. And since we have a by 2 outside, under root a square minus x square here. So finally we will get a square by twice of under root a square minus x square. This is the whole differentiation of the second part. Now let us combine it with a. We have to just add them. So this is a solution, this is b solution, which I regarded or indicated earlier. So we'll add them. So 1 by 2 is both have 1 by 2. So 1 by 2 I am taking outside, and I'll talk about this 1 by 2 later. I am subtracting now. Adding now. A square minus 2x square under root a square minus x square. I am writing this. And then we have to add it with a square by under root a square minus x square. So since the denominator are same, we can just combine the numerator. So it will be twice of a square minus 2x square. That is, denominator is same, a square minus x square. So a square plus a square is twice a square, and then we have minus 2x square. Now you can take 2 common. And you remember half was already there. I rounded it already. So just cancel this 2 with this 2. So a square minus x square by under root a square minus x square. So now multiply this under root a square minus x square, numerator denominator. Just multiply this. So numerator will give you a square minus x square into under root a square minus x square. Denominator and root gets cancelled. It will be a square minus x square. Now these two gets cancelled. Only under root a square minus x square will come. This is your final answer. This is your right hand side actually. So this is the final of this exercise. Thank you so much. Take care of yourself.